depending of what there is in the slide. Yeah, okay. So that is the typically what a Slurm script. It's basically a SH script. What your Slurm script will look like with different options. So those are basically the configuration that you will need to add inside. So basically, it will say if you use GPU, what will be the output of the log. Typically, when you run script, you will be able to see the log, and the log will be saved inside. For example, in my case, it will be saved in the current directory with the name my output, and it will save the output and the errors that are from the script. You will also need to give the name of the partition, and the partition is basically the name that we saw here. Okay. So those are partition names. So if you want to run on GPU 24 gigabytes, what you need to do is you need to change it this way. And for the rest, maybe we can directly see it inside the GitHub that I made. So now what you do is for CPU, I made 4 scripts that you can look at after this session to run script either on CPU or on GPU and in the array or not array mode. So array mode is being able to run multiple scripts with, let's say, with just one script. Let's say you want to run 10 scripts with some parameters. You just type array GPU, and this script will be launched 5 times. So 0, 1, 2, 3, 4. This is the index. And typically what you do with the index is you try to connect it with a CSV with parameters. So your CSV, basically you have 5 lines, and the first index of your CSV will be some parameters, and so on. And this can be accessed with the script. So each time you want to run a script, a new instance of your script will be run. So let's imagine that you have this Slurm script. If you have an array, this same script will be run 5 times with each time this changed. And this, so if it's not very clear, I will show you in live session what is the meaning of this. But basically, you want to run this, and for example, if you have, let's say you have like a script that have many parameters, what you want to do is you want to associate an ID for each experiment, so you can run different experiments with the ID. So that's basically the all use array. So now what we will do is I will show you some workflow, and the first one is
about the array. Is it possible to have like multiple arrays? So say I have 3 different models, I want to test multiple parameters on each of them. So I can have 2 different arrays to go through the models and the...
Yeah, you can run the array and then rerun another array and then rerun another array.
Yeah, but you can't have an array of array.
So basically,
yeah.
Like, having an array of array, you can technically you can have a for loop inside it, but it's not the right way to do it.
Yeah.
And now what I'll be showing you is basically how to run those scripts inside the cluster.
so how is the parameter like binded to this? Like suppose I'm changing my batch size in 5 different runs. So how is that batch size getting changed?
But in this case, you can, for example, write some You can have this,
Okay.
and then you link the index of this using,
Okay. I'll send it as a parameter to the script.
Yeah.
Okay.
and then you can have like
Okay. Got it.
batch size.
Yeah.
But this is the hard-coded way. You don't want to use this. You want to have a CSV inside your script that you will link with the array index. So let's say you have like a CSV with all your parameters, and each row represents an experiment. So you want to load, for example, Panda, and it will load all the parameters, and then you want to use this. So your script is using, so basically you have a parser that is directly linked to a CSV, and for each line of the CSV, it can be run a different experiment.
Okay.
So that's the correct way, but the easy way is to do it like this, and having directly index the slurm ID with the actual value inside.
Right.
Okay? Ok. Là, on est où à peu près? Ok. Donc ça, this is, those are the most important configuration inside the Slurm file. So those are what I mentioned here, and you need to write it like this. So you need to write this bin batch, and then hashtag followed by sbatch, and then the actual flag associated to the argument. And there is a bunch of arguments, but the most useful one are the one that I just presented. Okay, so you can give a name to your run. You can say for how much time it will run. So for example, you have a CPU job and you want to run for exactly 4 days. You can have like a limit days. You can write, you can say on which partition you want to use your GPU or your CPU, and you can have you can say which node you want to use. You can say how much node for task you need. So basically, if you have let's say you want to use 2 nodes, and for each node you want to use different GPU, you can say which CPU you want to use. You can also use the number of CPU per task. So it's basically a command that you add inside. So CPU per task. You can also add the number of RAM for your job. So it's mem and then followed by the RAM that you need for your job. And this is required GPU. Res equal GPU is required if you want to do a job with GPU. If it's CPU, this is not needed. And the time is this script will be run for 1 day if it's on GPU or CPU anyway. It will run for exactly 1 day. And those are basically the most important configuration that you need to do. And then what will be followed by this is just the Singularity command that we will run. And I will then show you now. And yeah, that's yeah. So something that I didn't mention that is also interesting is most of the time when you work with those Slurm command, when you add so for example, if I want to see all the jobs inside the cluster, I just have SQ. But if I want to see only my jobs or only a jobs from someone, I do SQ U followed by my name on the cluster, and I will only see my job. And typically, is what you want to do when you are monitoring your jobs, because sometimes there is like a huge queue with a lot of jobs, and it's very difficult to see everything. And also, what you can do, I mentioned 2 commands. the third command that is very important is s cancel, and this one allows you to cancel a job. So you cancel by giving the ID of your job. In my case, I will not do it because I don't want to cancel my job. But if you want to cancel this job, you type s cancel followed by the ID of your. You can also cancel by your ID name, so all of your jobs will be cancelled. So if you type this, will cancel all my jobs. Okay? And now, what we will do is un petit sondage, little sondage. So which one of you guys have time? If you do, you guys have time? The question is, do you have time, guys? No? Yes? Maybe 1 hour. 1 hour is okay?
Yeah.
Because we can finish in 10 minutes, but it will not be the same. Okay?
Ouais, du coup, je vais y aller avant que tu prennes plus de temps, parce que j'ai un autre de lire. Juste, j'ai avancé sur les slides, il y a un endroit où tu mets meilleur. Sorry, go back to English. Best practices for Slurm. And you say that we should use a scratch file system when we have input-output intensive tasks. In like 2 minutes, can you explain to me how it's done, like how the slash scratch and luster
It's just like flags that you add.
Okay.
It's not like a
You don't have to put your data on another partition
No.
or another folder.
It's like
it's just flags. Okay.
Yeah, just flags, and the thing is done by Slurm by default on the background. You do not see it. So
Yeah, okay.
it's like there's no extra configuration to do
So
this.
it's not a flag you should put inside of the Slurm file.
But it's the Slurm command. When you type the S batch that I will show you later, that's like you type it at this moment.
Okay.
Yeah. So okay, let's slow.
Yeah, I need to thank you for the lesson and the documents.
Yeah, I will try to. There is some when I did now the presentation. I just like thought about like adding some stuff. Basically, all the Linux commands that I mentioned earlier, they are present in the slide, but not very much. And also maybe add more details on the recipe of the yeah. And this, unfortunately, I could not like record with my PC, but there is a recording now, and maybe I will like share you this with you guys. But the idea is, I don't know if we see the screen correctly, but yeah.
You are not doing the screen recording?
No, I just like doing the. I was supposed to do it, but the thing with the sound is not working properly, so I deleted the thing. But maybe I will just restart it on my own and send it.
Thank you. See
you guys. So, other question, guys. Which one of you is using Python? We have question, huh? So, raise your hand, s'il vous plaît. So, every one of you is using Python. Which one of you is using Anaconda? Levez bien la main comme ça. Bien. So,
How do we know if we use Anaconda?
ah, ça c'est une mauvaise question. Hein? How do you use Python?
I don't know.
Do you use VM?
What?
Do you use a specific environment for your Python?
No.
Or do you install packages?
I installed Python 3.
Oh. You need to redo your education. young one. So, most of you are using Anaconda? can you raise your hand, those that are not using Anaconda, please? You do not use Anaconda, so all of you use Anaconda.
I don't know.
Okay, so starting from now, today, I will re-educate you, and every one of you, you need to use Anaconda. Okay? Anaconda is the best. Okay? Simple, no? Anaconda is the best, and it will make your life of basically working with specific environment and downloading packages way easier. And I developed during my PhD a pipeline that will allow you to convert your local environment, which is based on Anaconda environment, to a safe images in a very easy way, without most of the time any issues. So you have like the local environment with all your packages, all your library that you use in your local file, and you can transform this into a safe file that will be able to be run inside the cluster. And this is this pipeline will save you like I spent like weekends, nights. So you should be giving me money for this. But since I'm kind, because I'm very kind, I will just offer you guys the pipeline. Okay? So I will show you now what is this pipeline. But first, let's maybe use a pipeline that do not use Anaconda, that use just Python 3, like you mentioned. So most of the time, what you use is you are on your PC and you just use maybe if you just install in Ubuntu, you have like Python 3 by default or Python, and then you install all your packages inside the same environment, which is very bad. Very bad. C'est vraiment bad. Because there is like with time you need other packages that are different dependencies, and they can be like with time there can be like a lot of conflict, and then like there is like a simple prediction in 6 months, like you will have like issue with your product, with your environment. It's like 100% sure if you not already had like issue with your environment. So for how many times did you use this practice? First time? Usually, what do you do when you use Python? You're on your PC and you use Python like this. Yeah. So now, guys, please, when you go back on your PC, you go and you install Anaconda. Okay? Like this. You type Anaconda. It's very simple. For Linux, I guess. Okay. That also it's working for. It's also working with Windows and Mac. And what you do is you just download this and you run the sh script. That's it. For Windows, download the exe. That's it. And for Mac, I don't know what you do, but you do your thing. And the difference between Anaconda and Miniconda is just that in Anaconda it comes with a lot of tools, a lot of application and GUIs, and Miniconda is just coming with the small distribution that you need to just run Python. Anaconda comes with many tools, Jupyter Lab, Jupyter Notebook, a lot of things, Qt, PyQt, so a lot of things that most of the time not necessary. And Anaconda is just coming with the heart of Conda that allow you to handle and create and change Python environment. So basically, allow you to create basically the usage of Anaconda is to just create isolated Python environment. That's it.
One question. Like if we have Anaconda environment, then
If we have a,
if we have a Conda environment,
Yeah.
why do we need a .sif file?
but how do we in the cluster the only way to run script is with the SAF file.
Okay,
So-
then-
Inside the SFA file, you should have your Anaconda environment.
okay, so,
So
that is the base.
Yeah.
Okay.
You cannot run if you go in the cluster and you type Python something, your script, it will not run. It will maybe run with Python 3, but all your packages will not be installed. And it will not allow you to install the packages. So basically, the way that you are working is basically what is inside the cluster, but you cannot install all packages like this. You need to have like a isolated environment, because in the cluster it will not allow you to do pip install things directly on the root. It's not allowed because it's bad, very bad. Okay.
I don't know, so what are the differences between Anaconda and nothing for conflict? When you're doing your installation, it will be automatically done with Anaconda after when you add more package after.
So let's see now. So now, yeah. Bizarre. C'est là du direct, I guess. Bon, to answer your question is basically with Conda. So I will show you the basic command that you need to know with Conda. But you create isolated environments, and you can activate this environment and then install everything that you need. And if you want to work with another project, basically that do not need those packages, you create another environment with a specific version of Python, and you can install all the packages that you want.
Okay.
So the idea is to have like isolated Python environment with sub packages and a list of packages that is only required for the project. So basically the rule is one project, one Python Anaconda environment. That's it. That's the golden rule. Okay? So now you need to use these guys. Okay? Very important. Very, very important. I don't know why, but it seems that did something bad with Anaconda. Yeah, normally when you install Anaconda, you then when you run you like use terminal, you will be connected with base, the base environment. And what you want to do is you want to create a new environment for your own project. And to do this, what you type is conda create and the name of your environment. Let's call it like ml-env, for example, followed by Python equal the actual version of Python that you want to use. That's it. That's basically the idea. Then you tap enter. I will not tap enter because I don't want to create this env. But when you tap enter, it will tell you, do you want to install? You tap yes, and then you install it. And then what you do is basically you conda activate the script, the environment, and in our case, now that I did mention the conda and how to install, I will show you in live how we do the full pipeline to be able to have a local environment put inside a SIF and then how to transfer this to the cluster. Okay?
Just a question. For this, I mean, we will have a SIF file, on the page will be the Anaconda environment and our code that we will use this environment, or it will be separate?
Inside the SIF you will have everything. You will not need to have like the another thing that you need to copy to have this working. Everything will be inside. So to show you now how we do this as the following. So now if you have access to the Git that I showed, so you can open it now. It's like time to open it. And what we will do, since we do not have that much time, this one I will pass. But basically is the simple way to create a SIF environment with all the packages that you want. You do bootstrap docker, and you type from Python 3.9 Slim. It's like an image that is used on Docker Hub. That is basically Python 9. It is based on Ubuntu. And then inside it, in the post step, you can install all the packages that you want. And for example, let's say for science, let's say I will now run this. So if you remember correctly, what do I do now? Apptainer, what is the rest of the command to install this from a recipe? Okay, Apptainer build, nice. Who said this? Okay, build then.
The name of the C file.
Okay, name of the C file. So let's call it Python image. And what do I do next? Guys, didn't follow that much. So I use Apptainer, use build, I use the say the name. So what do I use now? What did I use for me?
To execute.
Yeah, I need to execute, but I need to link the recipe. And the recipe is at the end of the command line. And basically I add at the end the recipe to create the image. Okay? So this will create an Python image SIF that will be based on the recipe that I have now. Okay? Is this clear? Do I try to mess up with you and try to invent comment now? No? So let's test this. Oh, start building. Blah, start. Okay. Super cool. Install things, blah blah blah. And when it's done, it will create a SIF file that is called the name that I give it. So Python image.zip, and with this I can then run basically Python command inside it. So for example, I can do Apptainer what do you do next guys?
To run the image?
Yeah. Yeah, there is a run or exit. What should I use?
That's exit.
Exit or run?
We want just to run a command.
You listened. Exit, and what do I do next?
The name of the file.
The def file of the or the C file?
C file.
You listen. And then what do I do?
The command.
What command should I type?
Python.
Let's type Python and let's type version. Normally it should give me 3.9 since it's based on 3.9. Python 3.9. But okay, let's try something else. I know that inside this image, I do not have PyTorch. I know that it's not present inside. So if I try to import PyTorch, yeah, you're right. If I try to import Torch, it should not work. No, it's not. Yeah, it's not. It's not working, but it's not working for the good reason. It's there is a specific way to write the command since it's like a multiple command in the same time. Ouf, j'ai mal, hein? Oh. So this is basically a README that I added in the GitHub if you wanna do stuff yourself and try to like play with all the script that I added inside, and I would just show you this.
I have a question. You create a zip image file and you paste it into the cluster and just execute the zip and run the script inside of the image, and that is all right.
Now, for now, I just showed how to copy the code, how to create a zip file, and now I'll be showing you how to create a specific zip file of your Conda environment, and then after I will show you how to run the script with the zip file. But I didn't show you now how to run.
Right now the script hasn't been put into.
Yeah. Just have some connection issue, guys. Sorry. Seems that to connect.
Just a quick question. Why don't we just install all the packages we want during the definition file?
Great question. Great question. And the answer is that when you, for example, let's say you are working with your Python environment and you do a pip freeze with you to have like all the packages that are currently in your environment and you try to install this. When you do this by hand, most of the time you'll have issues. So when you install a lot of pipe packages with the exact version, and when you do this inside the security file, most of the time you will have like red warnings and the thing will not work. So I will show you how to do this when you have like a wrong pages.
What was the question?
So the question is basically, what do we need like basically Anaconda? What do we just need like? What do we just like install Python and just install all the pip packages?
Image.
Yeah,
Okay.
like I just showed.
Yeah. Yeah. So even I had the same question like .sif file is like I thought that Conda was sufficient with the environment, but .sif is needed for running the basic things.
So I will show you now what. Yeah, what I can do is let's cheat a bit. So during this time that like the connection is working, like letting me the access, I'll just like comment the code inside the GitHub. So as I mentioned earlier, when you want to create your Python environment, you use Anaconda all the time, always now, and you use it like this. Once Conda is installed, use Conda create -n, the name of your environment, and the exact version of Python. That's it. Then you activate, and then inside it, you use Conda and not pip to install your package. Most of the time, if you have the opportunity of doing this, use Conda. If the package is not present, use pip. But you need to know that if you are using pip, once you will be converting your environment to this zip file, there will be possible issues, and I will show you how to like mitigate or fix those issues. But if you install all the package with Conda, the pipeline that I used will allow you to have like a 100% success to create your images all the time. So that's the idea of using Conda. It's like you have like a transferable way, very easy, just from an Conda create a zip file present with all the packages that you have installed, which are based on the Conda installation and not the pip one. If you use pip, sometimes it will work. Sometimes you will have like a red warnings that will like make you like a lot of headaches. So to save this, make sure to always install packages with Conda. And if you do not have the opportunity, you can use pip. Okay. What I wanted to show you is basically this. Oh, now it gave me access. C'est terrible, c'est terrible. J'ai confiance. Confiance. Let's go. Arrête ça. Ok, lourd. Il m'a donné accès. So, now, just to like give you the when we install the Python image, we know that inside there is no torch. So just to give you like the actual comment, I know that all of those packages are present inside it. So I can just like Apptainer the exact the name of the Singularity file, which is Python something, Python image. And this should run and print all package imported successfully. All package imported successfully, as you can see. Not trying to mess with you guys. Okay, so now let's add, for example, torch. Instead of importing NumPy, I will try to import torch. And now it should not work because torch is not inside. No module found. Okay? And what we need to do in this case is what I will show you next. Is we want to update either the dev file with the recipe, we want to add like a pip install torch, or what what I'll be showing you is how to create a sandbox. And what is a sandbox? It's basically a directory that is present inside your local machine that is representing your SIF images. So it's basically having like a little a hard copy of your images that you can access inside it. So it's basically a repo with all the things that is present in the SIF file. And then you can connect inside it and rewrite things inside it. So it's basically a small copy of your isolated environment with all the files inside it. And you will be able to see the repo, and I will show you how to do this. And so yeah, now I just show you how you can create a Python Singularity images and run a code. And as I mentioned, when you do not have the package, it will not work. As I mentioned here, when I try to import Torch, it's not working. So now what we will do is we will create the same thing but with Anaconda, because Anaconda is the only right way to do it. When you work with Python and you want to work with any kind of data science project, you won't be able to have like isolated Python environment with the correct Python version and the correct amount of packages. Okay? So now the pipeline is the following. Let's go to the let's do it like this. So first, guys, all of you that have like Apptainer and Conda in your PC,